Alright, dear viewers. In this episode, I'll walk you through the pre-processing workflow for piano character rigs. I'll be using Blender throughout. But honestly, it doesn't matter which software you use. In theory, you can use 3ds Max, Maya, Blender, or any other modeling software. You could even use Unreal Engine. It's just that UE's editing tools are not so great. No matter which software, the core principle is the same. Right now, I'm working with Kinich's skeleton. When I first started developing Kiripple, I used Kinich's model in Blender to build the Kiripple prototype. Of course, it's been through a lot of iterations since then. So a lot of things in the original prototype are different from the current version and need to be updated. Alright, first thing we need to look at is the character's actual height. Whether you're working in Unreal or Blender, the character's height needs to be properly scaled. So let's fix it in the editor first. In Blender, go to the scene properties. Change the unit scale to 0.01. Keep it on metric, but set this to 0.01. After that, let's check Kinich's current height. Let me hide the keyboard first. He should be around 1.7 meters tall. Not sure exactly. Let me look it up. Well, the data I found surprised me. It says he's only 1.6 meters. That doesn't seem right to me. But since that's what the search results say, let's go with 1.6 meters for now. Let me add a height reference line. We'll draw what 1.6 meters looks like. Okay, so it should be about this tall. Now, let's select Kinich's skeleton. This is roughly 1.6 meters tall. The 1.7 meters you see here includes the hair, plus the mesh vertices on top. That adds up to 1.7, but actually, up to the head, it's around 1.6 meters. We don't need the height line anymore. Let's delete it, then apply the scale. Next, let's start inspecting the skeleton. My advice is, before making any changes, you need to display the entire skeleton. Show all of the bones, and carefully examine how the bone constraints work. Because the skeleton we get likely already has constraints on it. Especially some MMD skeletons, their constraints can be really complex for the skeleton we need. If it's going into an engine like Unreal, my recommendation is to avoid any constraints altogether. If you're working in Blender, you can keep some constraints and disable the ones you don't need. Because the only constraints we actually need control just these parts. The arms, and of course, the fingers. We need our keychains here. Then the legs. We also need our keychains. Finally, the upper body. From the waist up to the head. We need an eye keychain here too. All other constraints are optional. You can choose to keep or disable them. Next, we need to check the bone hierarchy in these areas. What kind of hierarchy works for our eye keychains? Let's take the arm as an example. The bone that controls hand movement is the wrist. I want its parent to be at the arm level, then up to this level. It goes straight up like this. Let's go into edit mode. Find its parent, it's this bone. The parent above that, it's this bone. A hierarchy like this is correct. The bones in between are twist bones, used for fine-tuning rotation along the arm. They don't affect the IK chain, We must ensure the hierarchy goes up like this. The twist bonds in between shouldn't be part of the IK chain hierarchy. The left hand is the same. This is fine. The foot is the same way. Tracing back from the foot's control bone, the actual control bone for the foot isn't this one. I've worked with MD a lot. The one that actually has DEF functionality is this bone. This one, 左手 DL, ankle DL. Where is its parent? It goes to this bone. It controls the lower leg. And above that, we can't see it clearly here. There's actually a bone around here. The foot's bone hierarchy isn't clear. We need to fix it. Because the bone we see isn't the same as the one that actually controls it. The hands are fine as they are. I'll remove the bones that are in the right position but don't have deformation. Then I'll find the bones that actually have deformation and move them to the correct positions. This one at the bottom doesn't have deformation, so I'll delete it. And finally, this bone on the foot is also useless. Alright, now the foot's bone hierarchy is properly organized. What you see is what you get. Next, we also need to check the upper body bones, starting from the waist. From here, go down one level and see if it goes straight to the head. This kind is clear. No problem. Also, I'll take care of one more thing. The twist bones in between have the wrong orientation. This is because after importing MMD into Blender, Blender's roll axis defaults to Y, which doesn't match MMD's convention. That's why the orientation looks weird. The fix is simple. We just make these bones all point toward their tip bone. And that's it. Alright. We've already sorted out the hierarchy for the IK chains. There are also some bones I added manually earlier. These are no longer needed, so I can delete them. Next up, we need to check the bone axis orientation on the IK chains. We need to click the Data tab, the green little man icon, and under Viewport Display. Show the axis. The axis requirements are simple. Bones on the same chain must have consistent secondary axis directions. In Blender, the primary axis is always Y. Let me pick a bone. Take this one as an example. The green one is the Y-axis. The dark blue one is the Z-axis. C and X are both secondary axes. We need to make sure that the other bones on the same IK chain have the same secondary axis orientation as this one. Its C-axis is pointing down, Z-axis pointing back. Let's check if the child bone is the same. C pointing down, Z pointing back. And the next level. This one also has C pointing down, Z pointing back. Now let's check if the right side is the same. The right one also has Z pointing down. X pointing forward is fine. Let's check if the next level matches. This one also has Z down, X forward. As long as the bones on the same chain have consistent secondary axes, it's fine. They don't have to match other chains. The tip bone's orientation is flipped. This is pointing down. This is also down. But after this point, it's flipped. Here it's pointing up. so we need to fix it. I'll turn off the symmetry toggle. Then add 180 to the row value. Done. Next, let's check the feet. Some checking criteria. This one has Z pointing back, X pointing left. Now let's check the next level. Yep, also Z back, X left. Next level down, this one is not Z back. It's slightly off. We can fix it. Wrong bound selected, should be this one. Next, let's check the right foot. Next, let's go check whether the fingertip positions are correct. The tip bone must be centered at the very end. Some bones are made roughly. The tip positions aren't always accurate, so we need to check. Kinage here is fine, no issues. If you're preparing bones for Unreal Engine, you need to make sure each finger chain has an extra tip bone at the end. This is also called a leaf bone. Even though this bone doesn't have deformation functionality, without it in Unreal Engine, it can't accurately pinpoint the fingertip position. Instead, it snaps to the previous joint. So you must add this leaf bone. Blender doesn't require this. Also check the orientation of each finger bone. Same as with the arms and feet. What follows are Blender-specific requirements. In Blender, the bones on an IK chain must form an arch, curving toward the bend direction. I'll use the pinky finger chain as an example. This bun chain right here. It needs to have an arch shape like this, arching toward the direction it bends, not a straight line. A straight line won't work. It must have an arch. Otherwise, the orientation will be wrong after adding IK constraints. If you find that a finger bone chain is completely straight, you need to select the two middle bones and move them up a bit. Make sure they are connected. You'll need to adjust this manually. If you're working in Blender, you're done at this point, because you don't need to export the skeleton. But if you're working in Unreal Engine, you need to select the character and its mesh skin. We'll zero out their transforms. Zero out the transforms for both the skeleton and mesh. Then select them both and export. When exporting, select armatures and meshes, and make sure animation is checked. Under armature options, don't check these two. Nothing else special. Just go ahead and export. Alright, that's the complete process for pre-processing character skeletons. Thank you for watching, and see you next time.